Welcome to this demonstration of the RADON Verification Tool. In this demonstration, you will see how command line version of the verification tool can be used to verify that a RADON model conforms to a specification expressed in the RADON Constraint Definition Language. This file shows an example CDL specification containing constraints and definitions. The first line imports an existing RADON model from another file. This imported RADON model contains definitions of various nodes, including two S3 buckets, uploads 1 and uploads 2, which are located in EU West 1 and EU West 2, respectively. The CDL specification expresses extra information that is not in the RADON model, such as the geographical locations of EU West 1 and 2 and some security constraints imposed by various countries. For example, the US is not willing to share its data with any other countries, whereas the UK is willing to share its data with every supported country. The specification also defines the pre- and post conditions of the createThumbnail lambda function. It takes as input a thumbnail from one of the supported countries, and guarantees to store it in at least one thumbnail bucket, but not in any thumbnail bucket located in a country with whom the country of origin is not willing to share. The verification tool can be used to check that the specification is consistent with the RADON model. In this example, we are checking that whenever the preconditions of a function are met, it is possible for the function to fulfill its post conditions. The tool has found two inconsistencies, which occur when a thumbnail originates from the US or China. The preconditions of create thumbnails are met, as the US and China are both supported countries, but it is impossible to meet the post conditions, as the US and China are unwilling to share data outside of their own countries, and no buckets are located in these countries. Now we will see how the verification tool can be used to suggest corrections to the RADON model. To do so, we must define a space of possible extensions to the RADON model. In this example, we may add elements to the set of thumbnail buckets and can define two new nodes. When run in correct mode, the tool searches the space of RADON model extensions for one which satisfies the specification. The tool iteratively searches for inconsistencies and finds a correction that fixes all inconsistencies found so far. In this example, the tool first fixes the US inconsistency by creating a new thumbnail bucket in the US. This does not fix the China inconsistency, so a second bucket is created in China. Expanding the space of RADON model extensions allows the tool more freedom in correcting the model. Letting the set of supported countries be revised allows the tool to find a simpler correction. The model is corrected by dropping the US and China from the set of supported countries. Allowing the tool to have too much freedom may not be advisable. In this example, the simplest way to ensure that all post conditions are met is to delete the post conditions. In future work, we will allow the user to define preferences over the RADON model extensions, potentially allowing the user to search for the cheapest or most secure correction. The final feature we will demonstrate allows the user to have complete control over the type of verification the tool is performing. The specification imports another CDL file which defines how to verify functions. In this case, we define a timeline of two time points. The first is assumed to meet the preconditions of a function and the second must meet the post conditions of the same function. The tool will search for an assignment to the first time point, such that the second time point is inconsistent. Allowing the user to choose from a possible set of verification types, or even define their own, gives the user complete control over the verification process.